Yes, write down these strategies. As you're writing them down, we're going to put a star, a green star and a green star and a number 1 beside both of those, because that was the first strategy I introduced to you, and it's the most important strategy. Can you change things to sine and cos and then get a common denominator? But in the proof that I just showed you, we now are introducing a second strategy, which is, those two are connected to the second strategy, which is changing or recognizing your Pythagorean identities. That tan squared is related to secant squared. Cotangent squared is related to cosecant squared. And sine squared plus cos squared equals 1. So often if you have the number 1 in an identity, chances are you're going to be using your Pythagorean identities because those have 1s in each of them. Sine and cos is still the big one. 90% of proofs you can, if you change to sine and cos and get a single fraction, you're guaranteed 2 out of 3 minimum on every single proof.
Like, do you ever have to use like the the ones that are known that like you get on like the Pythagorean?
These do you ever have to use those 3?
Like,
For sure.
Yeah, like do you ever like do you have to use them?
You don't have to.
Further break it down and actually
Right? We're going to get to some proofs where I'm not going to do them with sine and cos because they take 2 pages with sine and cos, and they take 3 lines if you use a different strategy. So,
but you could just.
but if you change it to sine and cos and work as far as you could get, you're not going to completely finish it, but you're going to get 2 out of 3.
So you would have to use the identities?
Yep. I'm going to put just a purple star beside that one, because you always want to do that one. And that's a simple strategy in that you're always aware of what's on the other side of your equation. This is going to help you whether you're going to use the number 1 strategy, changing to sine and cos, whether you're going to use the number 2 strategy and use a Pythagorean identity. You're going to take a moment to look at a proof and look at both sides and analyze it. Because sometimes you're going to recognize, hey, I need to use a Pythagorean identity. Or do you remember the proof that we did that the one side was in cotangent and the other side was in tangent? And the first time I proved it, I changed everything to sine and cos. And we did it, and it worked. We used strategy 1. We did it, and it worked. And then I said, hey, but if you recognize that one side was in cotangent and one side is in tangent, I can change the tangent side to cotangent easily. And then both sides are in the same trig function, and the proof was a lot faster when I did that. So being aware of what the other side is, in fact, the right side is giving you hints for what you should do on the left side. And the left side is giving you hints for what you should try on the right side. So being aware of what's on both sides is really going to help you. And finally, these last 3, I'm going to put in red and I'm going to put an S beside them for a strategy that you're going to use when you get stuck. That's an S. It's the strategy you're going to use when you get stuck. Okay? So sometimes, I sometimes even use this on tests. A student will go, I don't know what to do. Well, okay, if you don't know what to do, you can always change things to sine and cos and get a single fraction. And they'll say, I've done that already. It's still not work. So I say, you're stuck. And that's the hint that you need to use one of the stuck strategies. Now, I haven't explained them yet. One of them is self-explanatory. You know how to factor. Sometimes factoring is going to help you. So if you get stuck, you should say, is there anything that I can factor? Because maybe that will help me. But to build the other side and multiply by 1, that one we haven't seen yet, and we'll see probably tomorrow before your test, because we have our test third period. Okay, so let's go to example number 1. Everybody got this down? All right, so we're going to go through these proofs together, starting with A. So if it says prove, yes, it can be done. Draw your line, rewrite it, draw the line, because I wanted some more space on the left. Now I take a look. I take a look at this question. It has a tan, it has a secant, it has a cotangent, and it has a cosecant. And I know that there's a relationship between tan and secant because tan squared theta plus 1 is secant squared theta. But this one doesn't have anything squared. So in that sense, I'm thinking, no, I'm not going to use my Pythagorean identity. If it was squared, I'd be much more tempted to think I'm going to use Pythagorean identity. This one is our basic change to sine and cos strategy number 1. Let's change both sides to sine and cos. Let's get both sides to single fraction and see where that goes. So on the left-hand side, cotangent is cos over sine. And tangent is sine over cos. Cosecant is 1 over sine, and secant is 1 over cos. On the right-hand side, how do you multiply fractions? Multiply the top. No common denominator. Yeah, we're on the right side. Multiply the tops, multiply the bottoms, and we have successfully got a single fraction. On the left side, we have 2 fractions that are added. How do you add fractions? Yes, this is where you need your common denominator. So multiply by cos theta and cos theta, sine theta and sine theta. Now I have a common denominator. My denominator is going to be sine theta cos theta. My numerator, cos times cos, cos squared. Sine times sine, sine squared. So I have successfully got a single fraction on the left-hand side. Now sometimes when you get a single fraction on both sides, you're going to be done. But this one we're not quite done. We're close. Cos squared plus sine squared equals 1. You can use page 622. We're going to actually do the next one and one more that I've added. So, therefore, the left side equals the right side. Q, E, D.
Do you have to write out you changing like the cos squared theta plus sine squared theta to a 1?
If you didn't write this, you're not done yet. They're not the same. They have to be identical on both sides. So yes, you do need to change that. You can stop anywhere. I'm done. It's like prove each identity. Yup. Left side equals right side.
I mean, it's true.
My teacher told me that if it says prove, it's possible. So therefore, this one works.
So would you get a point? Would you at least get half mark because it is correct?
Did I? No.
Like
Did I tell you about the ladies and gentlemen exam? There was on an exam once the same, like a proof like this, and the student wrote, "Ladies and gentlemen, it is obvious that cotangent theta plus tangent theta equals cosecant theta secant theta. No work needs to be shown. The proof is done."
Did you at least give him a 0.5 for that?
No.
LS equals RS, please. Wait, so do you lose marks for not writing the left side equals right side?
because then we don't know if you've realized that they are the same. Like, not do any other work? No. No. Okay. So, all right. Second proof. Oh my goodness. We have a cubed. So, okay. So on the left-hand side, again, I'm going to take 10, 20 seconds to analyze what I have. I have cotangents and cosecants. My cosecant is squared. There's a relationship between cotangent and cosecant. Okay? So even though those three formulas are up on the wall and they're on your formula sheet, you have to have them memorized. Because if you don't have them memorized, you're not going to recognize things you need to do. Yeah, but if you have to look up there, you're going to miss it in the proof. You need to be able to, this proof has to say, it has to scream at you, oh, I should change this to cotangent squared theta plus 1. If you have to read your entire formula sheet every time, you'd be like, oh, should I use the quadratic formula in this one? No, it's a proof. But that's on your formula sheet if you're reading it for the first time. So we need to have all of our identities memorized so that you could recognize at this point that the hint of the left-hand side is telling me on my right-hand side, I should replace that cosecant squared theta with cotangent squared theta plus 1. If I do that, then my right-hand side has all cotangent squareds as well. Again, if you don't have it memorized, you most likely will change everything to sine and cos and use strategy 1, and this proof is much, much, much longer if you change everything to sine and cos and try to get a single fraction.
It's possible, right?
It's possible, but you would still have to use sine squared plus cos squared equals 1 later in the proof. And that might be hard to see. Okay. So now I can distribute my cotangent theta. And I get cotangent cubed plus cotangent theta minus cotangent theta. See that these are like terms? What's cotangent theta minus cotangent theta? It's going to just be 0. What do you need to develop? You need to develop practice in these so that you can start to recognize what's the fast way to do them compared to what's the long way to do them. And that only comes with experience. Would you have seen that you should change that cosecant squared to cotangent squared plus 1? Not now because you don't have those memorized yet. Okay? One of the ways that you memorize them is by using them more often. So by doing your homework and doing practice, you'll start to say, oh, I've used this more often. Okay? And here's the one I'm going to add as a third one to this. Okay, just a second. We're going to hide this part right now. There we go.
That wouldn't be on a
No, that would actually not help you. So here we'll draw our line. And we have a power of 4. Ugh. Squared. They're both squared on the right. That's a squared.
Is there a word for power, like to the power of 4 you say to the power?
Like you have cubed and squared. It makes a quartic function, but I don't know if there's a... So I don't know if there's a word for... So, again, we analyze both sides. We see that we have tan and secant, and because we have our formulas here memorized, we're like, oh, tan squared theta plus 1 is secant squared theta. Probably there's going to be a shortcut if I can use those, so maybe I won't change to sine and cos right away. Now, my formula for tan squared theta plus 1 equals secant squared theta works if I have squareds, which I have on the right-hand side. I don't have things that are squared on the left-hand side. Well, square rooting aside changes what it equals to, and you're not allowed to square root both sides because then you're working on both sides of the equation, which isn't allowed in a proof. Okay? But here on the left-hand side, you have to also be able to recognize that it's a difference of squares. Because how do I get tan to the 4? It's tan squared times tan squared. How do I get secant to the 4? It's secant squared times secant squared. And it's a difference of squares, so I can factor it to be tan squared theta plus secant squared theta and tan squared theta minus secant squared theta. And this proof is an example of a proof. If you don't know how to use difference of squares, you wouldn't get anywhere on this proof. Changing it to sine and cos would just make it a total mess. Really long, getting a single fraction on both sides, really long, and even more complicated than before. So, I factored it. At least I've got tan squared and secant squareds on the left-hand side now. Of those two factors, only one of those two factors actually matches up with tan squared theta plus 1 equals secant squared theta. So one of the things you have to be able to do mental math-wise is recognize, if I take this formula, tan squared plus 1 equals secant squared theta, is there any way that I could arrange it so that I could get tan squared theta and a positive secant squared theta on the same side? Can you see that that's impossible? If you move the secant squared to the same side as tan, well then the secant squared is going to be negative. And if you try to move the tan squared over to the right-hand side, the tan squared is going to be negative. So there's nothing I can do with the first factor. But the second factor, since one is positive and one is negative, that's possible. So then I'm going to manipulate my second factor. What can I change secant squared to? I can change it to tan squared theta plus 1. Perfect. What happens when you distribute that negative? Okay, I'll still have tan squared theta plus secant squared theta. And tan squared minus tan squared will be 0, and minus a positive 1 will be negative 1. Now, myself included, some of you will be able to mental math say, I can go from tan squared theta minus secant squared theta to minus 1. Can you see, though, that that would take two mental math manipulations here? You can move the secant squared to this side and the 1 to that side. So since that's two mental math things in your head, you have to show more work. You have to show this step in between. Okay? Because otherwise, like, I could do this to minus 1 in my head, and I could distribute that minus 1 to these two in my head, and I could get the final answer all in one step. But then I don't know if you're just copying down the right-hand side or actually doing it in your head. So we need to show our work so that you're not just sort of like, ooh, I'm stuck. Oh, and this is a very bad strategy to use in a proof. Don't do this. You're like, I'm stuck. I don't know what to do. So I'll just write the other side down so that it looks like I proved it. And then maybe I'll get a mark. Okay? Usually that results in -2 on the final exam. You lose. You've made a mistake, and that's why you can't get your proof. And then you make another mistake to make them the same. And so they deduct. You like lose marks for like trying to, like, oh, maybe if I like pretend that it works.
Yeah, but like,
You're better off stopping.
doesn't that mean you're just gonna get 0 on the proof anyway?
No, because sometimes you will have done some algebra right,
Oh, so
or like you've done the algebra right, but you made a mistake in your identities. So you're going to get 1 mark for your algebra. But then by writing it down to make it work, that takes away an algebra mark because it doesn't make sense algebraically to go from your mistake back to the right answer. So you got to be careful with those things. So for this one, if you didn't have the strategy of recognizing a difference of squares as a stuck one, this one would be very, very hard to prove. So we're going to learn about the other stuck ones tomorrow. Your questions for practice on this one are 3, 5, 6II, 7II, and 9II.